Let's do a practice problem. A company that receives the majority of its orders by phone conducted a study to determine how long customers were willing to wait on hold before ordering a product. The length of waiting time was found to be a variable best approximated by an exponential distribution with an average length of waiting time to be equal to 3 minutes. This means the mean number of calls answered within 1 minute is 1/3. What proportion of customers having to hold more than 4.5 minutes will hang up before placing an order? So please pause, work on this problem, and come back to see the solution. You have the formula right here. All right, let's see the solution. So here we have T, the waiting time of customers. It says it follows an exponential distribution with lambda equal to what? So it says the average length of waiting time is equal to 3. This means mu, which is equal to 1 over lambda, is equal to 3. This means lambda is equal to 1 over 3. So lambda is 1 over 3. Now we are looking to find the probability that the waiting time would be greater than 4.5 minutes, which is equal to, according to this formula, e to the power of negative lambda t, for lambda being 1/3 and t being 4.5. And that is equal to 0.2231. Next practice problem. A checkout counter at a supermarket completes the process according to an exponential distribution with a service rate of 6 customers per hour. A customer arrives at the checkout counter. Find the probability that the service is completed in less than 5 minutes. So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So here, if we define t as the random variable to be represented by the service time between two customers, according to the problem, it follows an exponential distribution with the rate lambda equal to, if you want to go with hour base, it would be 6 customers per hour. But in these types of question, you have to be careful because the question is asking for minutes base, 5 minutes, and the rate is given by hourly based. So you either have to go everything in hour based or everything in minute based. Let's go to have everything in hour based first. So we have to convert these 5 minutes into hour based. If you want to convert 5 minutes to an hour, what would it be? So 5 minutes is actually, if 1 hour is 60 minutes, what is 5 minutes in an hour? That would be 1 over 12. Why? Because 5 is equal to 60 minutes divided by 12. So 5 minutes is 1/12 of an hour. Therefore, our problem is the service is less than 5 minutes completed, so that would be t less than 5 minutes is 1/12 of an hour. So now we're going to use this formula here, and that would be 1 minus e to the power negative lambda, which is -6, multiplied by t, which is 1 over 12. So that's equal to 1 minus e to the power -0.5. Or we could go to a scale of minutes based instead, everything in minutes based. Let's go with that. So we have to convert this lambda to minute based. So we have 6 customers per 1 hour. 1 hour is 60 minutes. So this means we're gonna have one customer per 10 minutes. So if you have each 10 minutes you have one customer, this means that 1/10 of a customer would be served in 1 minute. In 1 minute, right? Because if you divide this by 10 and divide this by 10, you're gonna get 1/10. 1/10 of a customer in 1 minute would be served. So lambda is equal to 1/10. All right, now we have everything in minutes. We are looking for the probability that t is less than 5 minutes. And according to this formula, it would be 1 minus e to the power negative lambda, which is 1.1, multiplied by t, which is 5, which is equal to 1 minus e to the power negative 0.5. So we got the same answer. Six customer per hour, that's 0.1 customer or a tenth of a customer per minute. And the probability that the service time is less than 5 minutes is 1 minus e to the power negative 0.5, which is 1 minus 0.607, which is 0.393. All right, next question. What is the probability that the customer leaves the checkout counter more than 10 minutes after arriving? So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So here the question asks, what is the probability that the service time is greater than 10 minutes? So we're just going to use this formula, the complement of this formula, which is the probability that t is greater than or equal to t is equal to e power negative lambda t. So we're going to use this formula. So here it would be e to the power negative lambda, which lambda is 1/10. So it would be 0.1, negative 0.1 multiplied by 10, which is equal to e to the power negative 1. Which is about 37% almost. We could also use Excel. It has a function for computing the exponential distribution as shown here. So for this formula, if you want to do that, it's expon expon.dist. Then the first parameter here, x, is t, a small t here, which is 5. The next parameter is lambda, which is 0.1 that we found it here. And the last parameter is whether you are finding for cumulative or not, which we are really looking for cumulative here, both here and here. So it has to be true. So for part B, to find the probability that t is greater than something, that's why here we use 1 minus the probability. So that would be 0.368. The following question for the practice problem. So we want to find the probability that a customer that arrives at the checkout counter, the service rate for him or her is completed in a time between 5 and 8 minutes. So you have the formula here. So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So here again, the service time follows an exponential distribution. We're gonna go everything to be in minutes time. So minute scale, so lambda is 1/10 of a minute. And then we're gonna use this formula to find the probability. So the probability that t is between 5 and 8, the probability that t is between 5 and 8 minutes is e to the power negative 0.5 minus e to the power negative 0.8. And that's about 16%.